Hello my dear students. In first part of analysis of algorithm, we have seen introduction of analysis of algorithms and which factors you need to consider for analysis of algorithm. In second part of analysis of algorithm, we have seen how we can calculate time complexity for analyzing algorithms. And in this part, this third part of analysis of algorithm, we will see how we can calculate space complexity for an algorithm. So let's start with the space complexity. Okay, then we'll move towards calculation of space complexity and which factors we are going to consider for same with the help of examples. Now, what is the space complexity? The amount of memory required to perform any specific task that we can say as a space complexity. So, if you written any particular code algorithm, so amount of memory is required to store values in that algorithm, okay, that we can say as a space complexity. Or in another way, we can define space complexity like this: total memory space required by the program for its execution. For execution of program, how many total amount of memory is required, that we can consider as a space complexity. So for calculation of space complexity, we need to consider two things. First one is the fixed part and second one is the variable part. By considering these two things, we can easily calculate the space complexity of specific code. Now what is the fixed part? So whatever the variables are there which are independent of the characteristics of inputs and outputs, that we can consider in a fixed part. Means constant variable value which we have already assigned, that type of variables we are going to consider into the fixed part. Okay, and in second part, that is a variable part, we will going to consider the variables which have dependent on characteristics of inputs and outputs. Means variables which value is dependent on another variables, okay, or another things, that variables we can consider into the variable part. Another way we can say like this: variable which size is depends on a particular problem, okay, that variables we can consider into the variable part. So these two types of variable we are going to consider, and we will find out how many memory space required for these two types of variable, and by using that we will calculate the space complexity. So you can write down the formula for space complexity like this: S of P, space complexity for a particular program. This S indicate the space complexity, P indicate the program. Space complexity for a particular program is equal to C plus SP. The C indicates the fixed part. Okay, so whatever the variable which are independent on another variable, that we are considering into the C part. Okay, plus SP, it will consist of variable part. Okay, means variable which size is depends on another variable, that we are going to consider in this part. So let's see some examples. With the help of that example, we'll try to understand how we can calculate space complexity. Okay, so take this simple example first of all. Okay, so how many total variables are there in this example? A, B, C. These three variables are there. A, B, C. And all these variables are the integer value. For A and B having value as a 5, which is already initialized here. Okay, and for C we are calculating the value by using A and B. Okay, so A and B having 4 bytes, which required 4 bytes of memory to store this variable into the computer memory, because these variables are the integer types of variables A, B and C. Okay, only these three variables are there. So for storing this three variables into the computer memory, we require only just 4 bytes of memory. So in fixed part, we are going to consider A and B. Okay, so how much memory is required for the fixed part? we can write down formula like this: S of P, space complexity of this program, is equal to C plus SP. So what is C? C, we are going to consider the variables, okay, memory space required for the variables which are which size is not depends on other variables. So these are the two variables, okay, sorry, three variables which size is not depend on another variable. Okay, C is also variable which size is not depend on another variable. So these three variables, size required, memory required to store these three variables is 4 into 3. 4 bytes for each variable. Okay, so 4 into 3, that is 12. So total 12 bytes you require for this fixed part. Now consider this SP. SP is the variable part. So we are going to consider variable which sizes depends on another variable. But in this program there is no any other variable than this A, B, C. Okay, so in this example you just have C part, fixed part variable. So we are going to consider that here. For SP it is 0. Okay, so this SP, that is space complexity, for this particular program, space required for this particular program is 12 bytes. Okay, so how we can represent the space complexity? We can use big O of 1 for representation of this space complexity, because this is constant. At the time of time complexity, we have seen when time complexity is constant, any constant, it is 0, 5, 12, any constant, in that case your time complexity is big O of 1. Same way in here in the space complexity, if here is the constant value for space SP, then in that case we can represent it as a big O of 1. So this is the constant space complexity for this example. Okay, so let's see this example for better understanding. So in this example, how many variables are there? You can see n is there, I is there, and sum is there. One more variable is there, that is a. This a is actually array. Okay, so here how many variables are there? N, I, sum, okay, and a. A is an array. Okay, so you can see these are the integer variables. N, I, and sum, these are the integer variable. To store this integer variables in the computer memory, we require 4 bytes. Okay, and this size is not depends on any other variable. Okay, I will start with the 0. Okay, every time I will increment, so this value is not depend on another variable. Same way for sum and n also. So this variables we are considering into the fixed part. So total how much memory is required for storing these three variables into the computer memory? 4 into 3. 3 variables, each variable require 4 bytes. So 4 into 3, that is 12 bytes required for fixed part for this particular program. Now consider the second one, SP. So in SP we are going to consider variable which is depend on another variable, means which size is depend on another variable. So here is the array. Okay, our array name is A and size of it as a n. So we are taking n from user in this example. We have not declared that n. Okay, so array size is depends on n. Okay, if n is 2, array size will be 2. If n is 3, array size will be 3. If n is 10, array size will be 10. So array size is totally depend on n, means it is depend on another variable. So this type of variables we need to consider into the SP. Okay, so array we will consider into the SP, and this array will store all integer value. To store one integer value, how many bytes we require? 4 bytes. okay, to store one integer value. So if n values are there inside n values are there in array, how many memory space is required to store it? 4 into n. जैसे हमने यहाँ पे किया था 3 variables 4 bytes, so 4 into 3. So 4 bytes for each n for each variable, okay, and for 4 bytes for each variable, and how many variables are there? N. So total 4n memory space is required to store elements in an array. Okay, so that we can consider here as a 4n. Okay, so any other variable other than this n, I, sum, a? No, there are only 4 variables. This 3 comes under in the fixed part and this 1 comes under in the variable part. So total space required to store required for execution of this program, okay, 12 plus 4n. You can write down 4n plus 12 also. Okay, so this is SP. Okay, total memory space required. Now what is the space complexity for this? You need to consider this term which having a highest exponent, and that we can represent as a big O of n. Okay, so this we can say as a linear space complexity. As like of time complexity only, we will consider the highest exponent term, then we will ignore the constant multiplier, and then we will consider only this, and we will consider big O of n, because here we are considering the worst case. So in this way we can calculate the space complexity by using variable and fixed part of a program, where we are going to consider the variable which is dependent on other variable and variable which are independent of another variable. So in this way we can calculate the space complexity. So if you like my video, please like, share and subscribe my channel. Till then, take care. Bye bye.